So anyway, here we are. When we have a trig function, and this is a picture of the sine function, before we start talking about an inverse sine, we recognize that the only way, effective way to really do that is to get sine to be a one-to-one function. And so we look at it, sine itself is not a one-to-one function. There's, in fact, there's these two places, and if you follow this line along, there's many places where it will intersect, right? So it's each time you've got an input, there's an output value, so that's repeated many times. So what we're going to do is, as you can see over here, we're going to reduce the domain and basically say, okay, where would I cut it? So it comes up to here. Oh, it's going to start repeating here, so I'll just kind of cut it off here at pi over 2, and then if I cut it off back here at negative pi over 2, it all of a sudden gets this little graph that we see over here. We're going to need to do similar thing with cosine, but it ends up being different. But so when we talk about the inverse sine, which we'll define as inverse sine of x equals y, our domain goes from negative pi over 2 to pi over 2. So we relabel this. Usually we call this, instead of negative pi over 2, it's usually called, I think, 7 pi over 2, 4 pi over 2, that would be 3 pi over 2. So usually we call this 3 pi over 2, right? But going backwards, we're going to call it negative pi over 2. So that's the main thing. So this you should have hopefully picked up in your trig class, but again, I see I've left a few things. So what is the inverse sine? So the inverse sine is a function that when we take it, we get back to the angle. So we put in the so the idea is that whatever the sine of an angle is, that equals x. That gives us a value. When you put that x in there, that'll give you back the angle, right? So in this definition, y is an angle measured from negative pi over 2 to pi over 2. So thinking y is an angle, and x is in this case, a sine value, but we're going to use it in multiple ways, but this is a function value. And so if we look at the unit circle, we could define what would be the inverse sine of 1/2. And the way we would look that up is we look for where there's a 1/2. And remember, what we're looking at sort of backwards is where is sine 1/2? Well, here it is right here, because sine is the y coordinate. So what we're going to see is that if I want the inverse sine of 1/2, if that's the input, the output is going to be the angle, right? Y is the angle. So this would be pi over 6. Likewise, if I want to find the sine, the inverse sine, you'd also call this the arc sine, which you'll see it done in there. Say maybe of negative square root of 3 over 2. I look, okay, oh, it's not negative up here, but there's a square root of 3 over 2, but that's a positive one. Oh, here it is, negative square root of 3. So it's this angle here. Now, again, we're going to relabel this because we're going to relabel this as a negative pi over 2. So all of these, this would be, instead of 11 pi over 6, it's going to be negative pi over 6. So in a way, it's kind of easier. Negative pi over 4. And then this is just negative pi over 3. So I just took it off a unit circle, but when you're dealing with inverse functions, so we see this is what they're asking, the inverse of this angle. So they're asking what is its angle. So in this case, we'd say it is negative pi over 3. We could not list it as 5 pi over 3 because that is not in the domain, or it's not in the possible outputs here, right? Because y can't be, I guess it's not the domain of the sine function, so that we had to limit it to. It wouldn't be 1 to 1. So we've got to stay between negative pi over 2 and positive pi over 2. Okay, and then let's see some other features. I guess that was it. So one of the things you see is that when you take the inverse of sine of x, notice it will undo itself, so we get back to x. This will happen as long as you keep your, because it's going into the sine function first. To get the proper values, you have to restrict x to being between pi over 2 and, or negative pi over 2 to pi over 2. If we do it the other way around, again, we take the function of the inverse, we get back to x, but the key part is as long as x was between negative 1 and 1, because if it isn't, we won't be able to find it, right? So we're going to the inverse. The inputs have to be between negative 1 to 1. So as far as inverse sine, these that I'm circling here, these would be all the possible inputs. Of course, there's other inputs in here for non-standard angles, or I guess non-special angles. These are special angles. But for our special angles, these would be all the inputs we would really be dealing with, right? Just the y coordinates. Okay. Similar process for cosine. We'll just kind of highlight these. Again, we want to make it 1 to 1. Where do we go? Well, we can't go from negative 2 to pi, or negative pi over 2 to pi over 2, because that's not 1 to 1. So with cosine, the place we want to cut it is at 0, and then we come, and one full period would be here, and then we would start, you know, so we want to limit it from 0 to pi. So it's going to have a different domain. So it goes from 0 to pi. So that's the one thing to remember, is it's different than sine, because that's how we can make it a 1 to 1. We like to include the 0, but in a sense it's a little easier because all the angle measures are positive instead of having to go with negative angle measures, but that's how it works. So what are the details for inverse sine, or sorry, inverse cosine, arc cosine? Do the same thing. Inverse cosine of x equals y, so that means that the cosine of y equals x. That's what it means to be an inverse. And we define y to be an angle between 0 and pi. And just because that's what will make it work. That's what makes it 1 to 1. So in this case, when we look at the unit circle, we're using the top hemisphere. And the input values that we can put into an inverse cosine, are the arc cosine, right, are these values here, the x coordinates. And again, we could put the other ones, there's other angles, but these are sort of our special angles that we're used to using. But as we put these in, we get values back that are angle values. And the nice thing is with this picture, if I want to find the inverse cosine of square root of radical 2 over 2, negative, I want to find the inverse cosine of negative square root of 2 over 2. Sometimes I'm not even sure what I'm saying anymore. I look it up here, so this is what I need. What angle goes with that? 3 pi over 4. If I needed the positive square root of 2 over 2, I would say it would be pi over 4. So we look, but these are the values that we could be putting in. Okay. Let's see what else is on here. Oh, great! I wrote on the top of what I need. So let's go ahead and erase it. Okay, so you can kind of see that. So I'm just saying, if I take the inverse cosine of the cosine, I get back to x. That is only in the case where x is between 0 and pi, because if it's not, it's we could do a coterminal angle or something, you know, but we got to get it between 0 and pi. Whatever we do, x has to be between 0 and pi, otherwise it's not 1 to 1. And then also, if you take the cosine of the inverse cosine, right, you you're undoing whatever you do, so you end up back where you start. And that's true as long as x started out being between -1 and 1, because it's getting plugged into the cosine function. So those are all important things to take a look at.